Torsion is nothing but the twisting of an object when a moment is applied along its own longitudinal axis, or you can say when a torque is applied. Now torque is nothing but the moment which causes twisting. Now there are different kinds of failures which are there due to torsion. In case of the ductile material, the failure occurs along the vertical axis, and this failure occurs because of the development of maximum shear stresses. In case of the brittle material, the failure occurs in a slant plane, or you can say this basically is developed due to the development of various maximum tensile stresses. You must have seen in various kinds of experiments that the brittle materials basically fail in a slant kind of a way, because the brittle materials are not good in tension. And there are different kinds of shafts which are used. There are circular shafts, there are rectangular shafts, there are shafts with square cross-sectional areas. Now in case of the circular shaft, because it has a uniform shape, and there is no warping effect when a torsion or when a torque is applied, so which means that there is no change in cross-sectional area of that circular shaft. In case of the rectangular shaft, there is warping effect. Now in case of the circular shaft, basically the stresses, the shear stress basically increases from the inner part to the outer part, which means that at the borders there is maximum shear stress. So in case of a hollow circular shaft, basically it is considered to be as more effective, because most of the maximum shear stresses are taken care at the borders. Now moving further, there are various kinds of formulas which are there to find out different parameters in torsion. Like gamma can be taken out as rho theta upon L. Rho stands for the distance, any distance from the center. Theta stands as a straining angle. L stands for the length of the shaft, and the shear stress can be calculated as tau is equals to rho into T upon J. Rho stands for the distance from the center, T stands as the torque, and J basically stands as the polar moment of inertia. Now the theta can be calculated as theta is equals to TL upon Gj, and you know the other values. G basically stands for the shear modulus,